Okay, in this video we are going to answer the question what is the distance between a point Q and the line that is defined by a point P, any point P, and the direction of U, then the directional vector will define a line. So to have a line means to have at least one point and the vector direction U. This vector we will think as a unitary vector. Okay, so we want to find the distance between a point and the line. Well, the distance between a point and the line, there are many distances to the point, to the line. What distance we are going to find? We are going to find the minimum distance, and the minimum distance happens when the line crosses perpendicular when this distance d is the distance that we are going to find. How we will find? Well, this is the procedure to find this distance. Take U and put it here. Put it on Q. So this is the unitary vector U that you have drawn in the point Q. So the distance that we are going to find is this distance, d. V. This is the same distance d that we are going to find. So, how we will find? What is the data that we have? The data that we have is the line, meaning if we have the line, we have at least one point. You see that this distance is always the same whatever you choose the point P. If you choose the point P further, this distance will be the same one. If the point P is here, I'm going to erase it later. If the point P is here, the vector that goes from Q to P will be this vector, and the distance in the U direction, let's go to take this, in the U direction, the distance d will be again the same one. It's well-defined distance. D is the perpendicular distance. This distance. Okay, so let's go to erase this. Okay, let's go to erase. Okay, I leave it like this. Let's go to erase the point P and here. Okay, so how we will find this distance? This distance is related with the perpendicular, with this line. How we will do? Well, imagine that we have A and we have B, two vectors. What is that? Well, this angle is theta. And what is that? This part, this small part, is A magnitude of A cosine of theta. And this part is magnitude of A sine of theta. Okay, so let's go to choose the vector V, a unitary vector. So we repeat, this is U, a unitary vector. This is the vector QP, Q and P. What is this amount? This amount, the horizontal amount of distance. What is this distance? It's the magnitude of QP, the magnitude of QP by the cosine of the angle. So this is the angle theta, and the magnitude of QP, cosine of theta, is the horizontal distance, is this distance, but we are looking for this distance, that is the magnitude of QP, or PQ is the same magnitude, PQ and QP have the same magnitude, the magnitude of QP by sine of theta. So now let's go to work with this. The magnitude of PQ, or QP, let's go to put it like this. The magnitude of QP by the sine of theta is the distance d that we are looking. But this is, if we are going to find this distance, let's go to put this. Let's go to do it in using the cross product. If we do the cross product of QP cross U, what will be the magnitude of this cross product? It will be the magnitude of the first, QP, by the magnitude of the second, 1, by the sine of the angle that they form. Perfect. But this is D. So D is the magnitude of D. D is the magnitude of a vector C that is related with A cross B. Is related with QP cross U. The magnitude of this is D. QP cross U is D, the magnitude of QP cross U. So the problem is find U. We know the U. U is the direction of the line. Find QP. P is any. Q is the point that they give us. Q is the point that they give us, and P is a point on the line. We can find the point on the line, we can find QP, and we can find cross U, and we can find the magnitude of this vector. So let's go to do one example. But before doing any example, let me correct something. Here is the unitary vector. U is the unitary vector. So it's the magnitude of D, the distance D, is QP cross the directional vector of the line, but the unitary direction, the magnitude 1. Okay. Okay, so now let's go to apply our formula for the distance between a point and a rectilinear line is the unitary vector. The unitary vector U. QP, given the point Q, given the point P, any point P on the line, on the rectilinear line, we find the vector QP, we find the directional vector of the line, we do the cross product, and we find the magnitude, and this is the distance, the perpendicular distance between the point and the rectilinear line. So let's go to do an example. Let's say that Q is the point 3 minus 1, 4. Let's say that the equation of the rectilinear line is x of t equal minus 2 plus 3t, y of t minus 2t, theta of t is equal 1 plus 4t. Where is the directional vector? Is here, 3, 0, 4. So, 3 minus 2, 4. So the directional vector is 3 minus 2, 4, but this is not a unitary vector, so we need to find U unitary. So U unitary is found by taking U and divide by the magnitude. So if we do it, we will find that the unitary vector U in the direction of the line is 3 divided by square root of 29, I minus 2 divided by square root of 29j plus 4 divided by square root of 29. Square root of 29 comes by the magnitude of U. The magnitude of U is 3 squared plus 2 squared plus 4 squared. So we have the unitary vector U. So we have filled, for the moment, we have filled the information in the formula for U. Now we have to find QP. Who is P? P is any point on the line. Let's go to find any point. Make t equal 0. If you make t equal 1 also, you can make t any point, any t, so you can find the point x, y, and z. the easiest way is to put t equals 0. If you put t equals 0, the point is minus 2, 0, 1. So the point P is minus 2, 0, 1, and who is P? Who is P? The point P is minus 2, 0, 1, and who is QP? QP is OP minus OQ. Okay, QP is the vector that goes from Q to P. So it's OP minus OQ is the vector OP minus OQ. Perfect. So who is the vector OP? Well, the point P is the point 2, 0, 1. So who is OP? OP is minus 2i, 0j, 1k. The point Q is the point 3, minus 1, 4. So the vector OQ is 3i minus 1j plus 4k. So we have QP is OP minus OQ, which is this vector. We have U, that is this vector, but we need to use the unitary vector. So we need to find this one, that is the same one divided by square root of 29. Now we do the cross product. When we do the cross product, you already know how to do the cross product, you will find this result. And to this result, you will find the magnitude of this vector, the magnitude of C. The magnitude of the cross product of these two vectors is the distance D. Yeah, it's positive, of course, because the magnitude is something positive. If you make the numbers, it will be a square root of 6. So the distance between the line and the point, this is the point Q, maybe this is the point P, the distance D is a square root of 6. And the problem is solved.